Hello students. In this video, we're going to discuss about ICSE Grade 8 Chapter 5 Language of Chemistry. You know, people around you speak different languages. I know English and Tamil. Some know Hindi, Marathi, Spanish, French, and so on. There are numbers of languages. Where this language originated from? Let's see. Early men started writing in caves. He used some symbols as their language. Then came alphabets in different language. When these alphabets combine, they form words in different languages. Words of all different languages form sentences. Combination of different words form sentences. Alphabets combine to give words. Words combine together to form sentences. Chemistry, a separate branch of science, has its own language. This language is known as language of chemistry. Languages as alphabets. Same way, language of chemistry as symbols. In this chapter, we'll be discussing about elements and their symbols, formula of compounds, chemical equations, law of conservation of mass, balancing chemical equations, information gathered from chemical equation, limitation of chemical equation. An element is defined as the simplest or the basic form of a pure substance, which can neither be broken into nor made from simpler substances by any physical or chemical method, which means you can't change one element into another element. One element cannot be transformed into another element by any physical or chemical methods. Example, you take iron. Iron cannot be transformed into gold. Gold cannot be transformed into iron, not only iron, into any other elements. If you break iron, you'll get a pieces of iron as small as possible. Even then, these small pieces are of iron. When you break iron objects, you'll get a pieces of iron. You won't get a pieces of any other elements. Moreover, iron cannot be built from simpler substances as it is a simple substance in itself and it is extracted from the iron ore which is naturally present in the earth crust. So, an element contains only one kind of atoms. Example, you take a copper. Copper is an element made up of copper atoms only. Carbon. Carbon is an element made up of carbon atoms. Helium, which is made up of only one type of atom, that is helium atoms. An element contains only one kind of atoms. Elements are purest form of substance. And elements may combine to form compounds, but elements are the purest possible substances. This is because they cannot be transformed into other chemical substance in any normal chemical reaction. You can't transfer gold into an iron or iron into gold. If a solid, liquid, or gas is made up of only one type of atom, we say it is an element. For example, consider a tripod made up of iron. It contains only one types of atoms, iron atoms. These atoms are all iron. There is nothing else in here. So this tripod stand, which is made up of iron, it's an element. Next, symbols of element. What is the name of this actor? I asked many members. They said SRK. His actual name was Shah Rukh Khan. Most time people remember as SRK. Why so? It's easier to remember and recall shorter names. Since SRK is a short name, it can be used more frequently. Similarly, chemistry, there are 118 elements discovered so far. All are big names. In order to use again and again to write them again, it's tedious and difficult process. We use short form. Symbol is a short form of an element. Before 1600 AD, Alchemists tried to represent the substance that they used for the experiments by different kinds of pictographic symbols, such as triangle for earth, crescent for silver, etc. Dalton used some other types of symbols to represent elements, such as a circle for an oxygen, a circle with a dot in its center for hydrogen, etc. Antony Lavoisier was the first to use a modern names of elements. Later, John Jacob Berzelius suggested the initial letter of an element written in capitals should represent that particular element, such as oxygen, O for oxygen, H for hydrogen, C for carbon, and so on. Chemical symbols may be a single or two-letter representation used to denote full name of the elements. So symbols may be single or two-letter representation used to denote full name of the elements. Here this oxygen, O for oxygen, Ca for calcium. Guidelines for writing the symbols of different elements are: symbols of an element. Symbol of an element is the first letter and another letter. See, they clearly mention another letter. It's not necessary to be a second letter. It may be a second or another letter of the name. So symbol of an element is the first letter and other letter of the English name or Latin name of the element. Element name hydrogen. Symbol H. It's a first letter. Second example, element name magnesium. Symbol Mg. First letter, third letter. Third one, cobalt. Symbol of this element is Co. First letter and second letter represents the name. The symbol of an element is the first letter and another letter of the English name or Latin name of the element. The first letter is always capital and the other letter, if added, is always small letter. So here Al is the symbol of aluminium. The first letter always should be in a capital form. The second letter should be a small letter, always a small letter. A, small l. Second one, nickel. Ni, capital N, small I. This is the symbol of nickel, capital N, small I. The necessity of adding another letter arises only in case of two or more elements starting their names with the same letter. Example, calcium, chlorine, chromium, cobalt. These elements starts with same letter C. So in that cases you have to introduce another letter. You have introduced another letter. Ca for calcium, Cl for chlorine, Cr for chromium, cobalt, Co. So whenever you introduce the second letter, the first letter should be in a capital form, second one should be always small letter. Another letter added to the symbol is not always the second letter of the name. Example, magnesium. So here, magnesium and manganese, as these elements' names start with the same letter M, they have introduced another letter from the name, but here it's a third letter. In this case also it's a third letter. It may be a second or third letter, and it is not necessary to be a second, and it's not necessary to be a third letter. Maybe any letter. So it's a magnesium Mg, manganese Mn. Symbols of some elements have been taken from the names of elements in Latin or other languages like German or Greek. This one, calcium, is an English name, and the symbol of calcium is derived from its English name, calcium. But potassium, the symbol of potassium is K. The symbol is taken from Latin name, gallium. Some of the elements having Latin names: antimony, symbol of antimony Sb, as taken from the Latin name stibium. Copper, it's Cu, taken from the Latin name cuprum. Gold, symbol of gold is Au, Latin name Rm. Iron, symbol Fe, as taken from the Latin name ferrum. Lead, it's Pb, taken from the Latin name plumbum. Element name mercury, symbol of mercury is Hg, as taken from hydrargyrum Latin name. Potassium, symbol of potassium K, as taken from the Latin name callium. Silver, symbol of silver is Ag, as taken from the Latin name argentum. Sodium, it's Na, is taken from natrium, Latin name. Tin is Sn, as taken from stannum. Tungsten, symbol of tungsten is Tw, as taken from the Latin name Wolfram. It's not Wolfram, it's a German, it's not a Latin name, it's a German name, Wolfram. Most of the symbols are similar to the name of the element, but some symbols of elements have Latin roots. An example for this, silver, which is denoted by Ag, from its Latin name argentum. Iron, symbol of iron it's Fe. It has taken from the Latin name ferrum. So most of the symbols are similar to the name of the element, but some symbols of elements have Latin root. Some elements with the first letter as their symbols: hydrogen, oxygen, sulfur, nitrogen, phosphorus, carbon, boron. Some elements with two letters as their symbols: chlorine, calcium, chromium, cobalt, magnesium, manganese. Next, we're going to discuss about valency. The valency of an element is a measure of its combining power with other elements. Example, you take hydrogen. Valency of hydrogen is 1. Valency of chlorine is 1. Valency of carbon is 4. As the valence of hydrogen is 1, the combining power of hydrogen is 1, so that it can combine only with only one element. Okay, it can make only one bond with another element. Example, you take hydrogen chloride, HCl. Valency of hydrogen is 1, chlorine is 1, so that chlorine is combined with only one element. Hydrogen valency is 1, so that hydrogen combined with only one element. But in this case of methane, this is structure of methane. This is the formula of methane, CH4. This is the structure. See, carbon valency of carbon is 4. Carbon has tetravalency, so that it can make a 4 bonds with other elements. It can combine with 4 other elements. But hydrogen, it can make only one bond. It can combine with only one element, so that one carbon combined with 4 hydrogen, but this hydrogen combines with this carbon, this hydrogen combines with this carbon. Hydrogen combining power is 1, but carbon combining power is 4, so that it combined with 4 hydrogen. It has formed 4 bonds with 4 different hydrogen. Valency is measured in terms of hydrogen atoms or oxygen atoms. How? It is the numbers of hydrogen atoms or double the numbers of oxygen atoms that can combine with it. Example, We have discussed valency of carbon is 4, valency of hydrogen is 1. Combining power of carbon is 4, combining power of hydrogen is 1. Here it is a number. Valency is the number of hydrogen atom or double the numbers of oxygen atom. Numbers of hydrogen atoms that can be combined with. So here the carbon combined with 4 hydrogen atoms, so the valency is 4. Double the number of oxygen atoms that can combine with it. So valency is the measure of the double the numbers of oxygen atom that can combine with it. So we are measuring valency in terms of hydrogen atoms or oxygen atoms. So valency is the double the number of oxygen atom that can combine with it. Carbon, valency of carbon is 4, so that it can make 4 bonds with other atom. Oxygen, valency is 2. It can make only 2 bonds with other atom. So carbon form 2 bonds with right hand side oxygen, 2 bonds with left hand side oxygen. So valency is the measure of oxygen atom, that is double the number of oxygen atom that can combine with it. Here the carbon, as it is combined with 2 oxygen atom, the double the numbers of oxygen atom it has combined will be its valency. As it is formed combined with 2 oxygen atom, valency is 4. Carbon valency is 4. Or modern definition of valency: the number of electrons that an atom can lose, gain, or share during chemical reaction is called its valency. All the elements try to achieve stable electronic configuration as like group 18 elements. Except group 18 elements, all the elements try to achieve stable electronic configuration. So they involve in chemical reactions by losing, gaining, or sharing of electrons. Why they are losing, gaining, sharing electrons? In order to achieve stable electronic configurations, that is octet electronic configuration in their outermost shell. First, you need to understand how you are getting this cation. So, sodium, atomic number of sodium is 11. It has 11 protons and 11 electrons. After it loses 1 electron, the numbers of electron will be 10. When you take total charge, you'll get 1 extra positive charge. But here, it has 11 proton, 11 electron. Sodium atom normally has 11 protons and 11 electrons. When you take total charge, you'll get a 0. But after it loses 1 electron, the numbers of electron will be 10, numbers of proton will be 11. Then when you take a total charge, you'll get a 1 plus 1 charge, extra positive charge, plus 1. Okay. As it has 1 extra positive charge than the normal, we are representing it by writing over the sodium atom, so that you are getting a cation. After it loses the electron, you will have a 1 extra positive charge than the normal. So we are indicating it by writing over the sodium. This is actually sodium cation. What about the potassium? Potassium atomic number 19. So it has 19 protons, 19 electron. After it loses 1 electron, the number of proton will be 19. Number of electron will be 18. One number lesser than the normal. So when you take total charge after it loses electron, you will get 1 unit of positive charge. So it has 1 unit of positive charge than the normal. So that we are indicating by writing it over the potassium atom. So this is what? Potassium ion. This is potassium ion, a cation. But what about the sulfur? Sulfur, atomic number 16. Numbers of protons 16. Numbers of electrons 16. When you take total charge, you'll get 0. Atoms are always electrically neutral as it has equal numbers of protons and electrons. But after it gained 2 electrons, the numbers of protons will be 16, number of electron 18. When you take total charge of this, you'll get 2 extra, that is what, 2 unit of negative charge. So it has 2 unit of negative charge than the normal. So that we are indicating it by writing over the sulfur. This is how we are getting this anion. This is a sulfide ion. So sodium, why it's losing one electron? Here we have discussed, right? Sodium lose one electron. After it lose electrons, you are getting a sodium ion. Why? Actually, this is the electronic configuration of sodium 2,8,1. It has one extra electron to achieve stable electronic configuration. So, in order to achieve stable electronic configuration, it's tried to lose this one electron. After it lose one electron, automatically it achieve stable electronic configuration. You are getting Na plus. As it has only one unit of positive charge, it's known as monovalent. Valency is 1. Magnesium, electronic configuration 2,8,2. It has 2 extra electrons to achieve octet electronic configuration. It is stable electronic configuration. So it has greater tendency to lose these 2 electrons. After it lose 2 electrons, the electronic configurations will be 2,8. It lost 2 electron. After it lose 2 electron, when you take a total charge, you'll find 2 extra unit of positive charge than the normal, so that we are writing Mg2 plus. It has lose 2 electron. So the valency is 2. It's a divalent. It's known as divalent. What we have discussed, the numbers of electron that an atom can lose, gain, or share during chemical reaction is called its valency. So here, sodium has lost 1 electron. The valency is 1. It's known as monovalent. Magnesium lose 2 electron. So the valency is 2. It's known as divalent. Aluminium, which has 3 electrons in the outermost shell, lose 3 electrons to achieve stable electronic configuration. So the valency is 3. It is known as trivalent. Chlorine. Electronic configuration of chlorine 2,8,7. Chlorine, it is in need of 1 electron to get stable electronic configuration. After it gains 1 electron, the electronic configurations will be 2,8,8. As it has gained 1 electron, the valency is 1. Valency, what we have discussed about the definition of valency, the modern definition, the number of electrons that an atom can lose, gain, or share during a chemical reaction is called its valency. As it has gained 1 electrons to get stable electronic configuration, valency of chlorine is 1. After it gain 1 electron, when you take a total charge, you will get 1 unit of negative charge. 1 unit of, you will find 1 extra unit of negative charge than the normal. So that we are writing over it chlorine, you are getting an anion. As it has gained 1 electron, the valency is 1 and it is known as monovalent. Oxygen, electronic configuration of oxygen is 2,6. As it is in need of 2 electron, it tried to gain 2 electron. After it gain 2 electron, the electronic configuration will be 2,8. As it has gained 2 electron, the valency is 2. It is known as divalent. Nitrogen, electronic configuration is 2,5. It is in need of 3 electron. After it gained 3 electron, the electronic configuration is 2,8. As it has gained 3 electron, the valency is 3. It is known as trivalent. Numbers of electrons in outermost shell, valency. Numbers of electrons when 1, 2, 3 in the outermost shell. The element has more tendency to lose the electron. When it loses 1 electron, the valency will be 1. If it loses 2 electron, then valency is 2. If it loses 3 electron, valency is 3. When the outmost electron is 1 or 2 or 3, an element or atom has more tendency to lose the electron and get valency 1, 2 or 3 respectively, and it behaves as a metal. Atom or element which has 1, 2 or 3 electrons in the outermost shell behaves as a metal. When atom has 4 electrons in the outermost shell, it can lose, gain or share electrons. So most probably the atoms, the element which has 4 electrons in the outermost shell behaves as a metalloid. When atom or an element has 5, 6, 7 electrons in the outermost shell, 5 or 6 or 7 in the outermost shell, has greater tendency to gain electron. All the atoms try to achieve stable electronic configuration, that is, try to achieve 8 electrons in the outermost shell. When it has 5 electrons in the outermost shell, instead of losing 5, it has more tendency to gain 3 electrons to get stable electronic configurations, that is, to get 8 electrons in the outermost shell. So in same way, when it has 6, instead of losing 6, it has more tendency to gain 2 electron. When it has 7, it has more tendency to gain 1 electron. So when the outermost electron 5 or 6 or 7, valency will be 3 or 2, 1 respectively. And the elements which has 5, 6 or 7 electrons in the outermost shell mostly behaves as a non-metal. The elements which has 8 electron in the outermost shell are more stable. They won't participate in chemical reaction. So they won't lose, gain, share electrons. So the valency will be 0. Electronic configuration of calcium is 2, 8, 8, 2. It has 2 electrons in the outermost shell. So it behaves as a metal. Calcium is a metal. Chlorine. Electronic configuration of chlorine is 2, 8, 7. As it has 7 electrons in the outermost shell, it has greater tendency to gain 1 electron and behaves as a non-metal. Neon. It's a group 18 element. Electronic configuration of neon is 2, 8. Already it has 8 electrons in the outermost shell, so it won't participate in any chemical reaction. The valency is 0. Group 18 elements is known as inert gas or noble gas elements. Thank you so much, students. Hope you have liked this video. If you have liked this video, click the like symbol. Subscribe my channel for more videos. Share to your friends. Keep returning to my YouTube channel. Thank you.